We explore the marvels and mishaps of engineering. Today, we're taking a thrilling and sometimes terrifying look into the world of aviation. We're talking about the planes that were so ambitious, so cutting edge, that they pushed the very boundaries of what was possible. These are the most dangerous experimental aircraft in history, the machines that taught us invaluable lessons, often at a great cost. So buckle up as we dive into a story of high-stakes innovation, brilliant minds, and incredible bravery. Let's start our journey in the jet age, a time of unprecedented speed and power. If the X-1 was a bullet, our next aircraft was a missile with a pilot strapped to it, the Bell X-2 Starbuster, designed to fly even faster. And higher than the X-1, the X-2 aimed to explore speeds beyond Mach 3. This introduced a whole new set of dangers, primarily the thermal thicket, intense heat generated by air friction at extreme speeds. The plane was built from stainless steel and a copper-nickel alloy to withstand temperatures that would melt conventional aluminum, but the real danger lay in its flight characteristics at high speeds and altitudes. The X-2 was notoriously unstable. In 1956, Captain Milburn Apt broke the Mach 3 barrier, but immediately after, the plane went into an uncontrollable tumble known as inertia coupling. He was unable to regain control or eject successfully, and the tragic crash highlighted the perilous new challenges of hypersonic flight. The X-2 program was cancelled shortly after, but its data was crucial for future designs, proving that even failures can pave the way for progress. Now let's talk about a plane that looked like it flew straight out of a science fiction movie, the Northrop X for Bantam. Its goal was to test a radical idea: could a semi-tailless aircraft be stable at transonic speeds? The designers got rid of the horizontal tail surfaces, believing they caused stability problems near the speed of sound. The result was a sleek, dart-like plane. The problem? It turned out those tail surfaces were pretty important after all. The X-4 was notoriously unstable. Pilots reported that it flew like riding a tricycle on ice, with a tendency to pitch up and down uncontrollably. It was a handful to fly at any speed, but near Mach 1, it became a wild ride. While no one was fatally injured flying the X-4, it was considered a dead end in aircraft design. But it taught engineers a valuable lesson. Sometimes conventional wisdom is wise for a reason. By showing what didn't work, the X-4 indirectly helped designers understand the complexities of transonic aerodynamics for future successful aircraft. Moving on, we have an aircraft that wasn't built for speed, but for something just as revolutionary: vertical takeoff and landing. Meet the Ryan X-13 Vertijet. This was a true tail-sipper jet. It took off vertically, straight up like a rocket, then transitioned to horizontal flight, and finally landed vertically by hooking onto a special cable on a mobile trailer. Imagine the skill required to back a jet engine down onto a tiny hook. The concept was mind-blowing, but the execution was incredibly risky. There was no room for error. A slight miscalculation, a gust of wind at the wrong moment, or an engine hiccup during the delicate transition phase could lead to disaster. The pilot's visibility during the vertical landing was extremely limited, forcing them to rely on instruments and guidance from the ground crew, while the X-13 successfully demonstrated its capabilities in numerous tests. The sheer complexity and precision required made it impractical for widespread military use. It was a fascinating but dangerous experiment in rewriting the rules of takeoff and landing. But what if you wanted to go really, really fast? I mean, absurdly fast. Let's shift gears from pure speed to a different kind of danger. Stealth and unconventional design. Enter the Tacit Blue, also known as the Whale. This bizarre-looking aircraft, with its curved top and flat bottom, was a top-secret technology demonstrator for battlefield surveillance. Its main purpose was to test advanced stealth characteristics, specifically a low radar cross-section and a low probability of intercept radar system that could scan enemy positions without being easily detected. The plane's shape, which earned it its cetacean nickname, was dictated by stealth, not aerodynamics. As a result, it was inherently unstable. It relied on a complex quadruple redundant, digital fly-by-wire system to stay in the air. If the computers failed, the plane was unflyable. Test pilots reported that it handled sluggishly and was a real challenge to fly. Operating in secret out of Area 51, the pilots of Tacit Blue flew 135 sorties, pushing the envelope of what was possible with stealth technology. It never fired a weapon, but the lessons learned from its risky flights directly influenced the design of later stealth aircraft like the B-2 Spirit bomber. Finally, we have to talk about a true Frankenstein's monster of the skies, the Fisher P-75 Eagle. developed during World War II. This plane was an attempt to create the ultimate interceptor by combining parts from several different aircraft. It used the wings of a P-40 Warhawk, the tail of an A-24 Dauntless, and the landing gear of an F-4U Corsair. All of this was wrapped around one of the most powerful piston engines of the era, the Allison V3420, a massive 24-cylinder engine that was essentially two V12s joined together. The idea was to quickly create a super fighter. The reality was a disaster. The Frankenplane was overweight, had a terrible climb rate, and was plagued by engine cooling problems. Its center of gravity was way off, making it dangerously unstable. Test pilots found it incredibly difficult to handle. The P-75 Eagle was a textbook example of how simply bolting together the best parts doesn't guarantee a good aircraft. It was a dangerous, ill-conceived mess that was thankfully cancelled before it could see combat. It serves as a powerful reminder that in aviation engineering, the whole is much more complex than the sum of its parts. These aircraft, from the sound barrier breaking X-1 to the clumsy P-75, represent the sharp edge of innovation. They were flown by pilots of extraordinary skill and courage, who risked everything in the name of progress. Each flight, whether a success or a failure, contributed to the vast pool of knowledge that makes modern aviation as safe and reliable as it is today. They remind us that every smooth commercial flight we take rests on a foundation built by these dangerous, daring, and revolutionary machines. Thank you so much for joining us on this high-flying adventure into aviation history. If you enjoyed this look at the razor's edge of engineering, please hit that like button and subscribe for more deep dives into the world of science and technology. Let us know in the comments which experimental plane you find the most fascinating. Until next time, stay curious.